Hello, everyone, and welcome to our latest DZone webinar. My name is Jason Cockrum. I am the Community Engagement Manager here at DZone, and we're glad you're here with us today. We've got a really relevant and an exciting topic, so we're happy you've joined us. If you're new to DZone, we are one of the world's largest online communities of software developers and experts, and we publish all sorts of knowledge resources for developers and really anyone involved in software development. We've got all kinds of stuff from ref cards and trend reports to thousands of articles written and published by people in our community. And this all makes us kind of the go-to knowledge hub for developers all over the world. We also do a ton of great events like the one you're about to see today. And you can find all of them on our website at dzone.com/webinars. There you can see past events, on-demand webinars, upcoming events that cover a huge range of topics. So be sure to check that out. And joining me today, we have George Hamilton and Eric Chabel from Chronosphere. George is the Director of Product Marketing at Chronosphere with over 25 years of experience in the technology industry. And he's held many product marketing roles at leading global tech companies all over the world, such as Cloud Health by VMware, Xavia Labs, Digital.ai, and Dell EMC. And he's also spent some time as an industry analyst covering IT systems management and application performance monitoring. Eric is Chronosphere's Director of Evangelism, and he's already well known around the developer community as a speaker, a lecturer, author, and baseball expert. So if you ever have any baseball questions, be sure to ask. He's passionate about helping companies and developers understand the challenges of cloud-native observability and how to overcome them. He's got a really unique perspective, and so we're really glad that he's here today. And he's dedicated his entire professional life to sharing his expertise of open source technologies and organizations, so we're really glad that he's joined us. George and Eric are going to spend a little bit of time talking about some of the biggest challenges that developers face today in building efficient, productive workflows, something I think we can all relate to, and how cloud-native observability can help overcome these challenges. Then at the end, they're going to answer any questions you might have had about what they've discussed. And I want to remind you that DZone is all about community, so we encourage you to get involved and get engaged in the conversation. On the right side of your screen, there's a little box where you can chat with other attendees and talk about what you're hearing today. You can share your experiences with productive workflows and observability and all those things. And there's also a box where you can submit questions to George and Eric, and they'll do their best to answer as many of them as they can towards the end. So at this point, I'm going to go ahead and hand it off to George. George, take it away.
Thank you very much for the great intro. And also, think of questions to ask. Eric and I are happy to answer any questions you ask throughout the session. So we appreciate that. And hopefully we can generate a few questions as we go through the slides here. So when we say shift left observability, I know Eric's written several blogs on this topic, and what we're really kind of focusing on is, there's a lot of talk in observability, logs, traces, metrics, and the 3 pillars, and getting your costs under control and things like that, and trying to grapple with the amount of data being generated from cloud native environments. And I think some of the things that are not talked about as much is how much pressure is on development teams to optimize applications, and how do we make their jobs easier? Burnout, really, and we've heard this so much, especially coming out of the pandemic phase, where burnout for DevOps teams and SREs is at like record highs, where their job satisfaction is plummeting and they're overworked. And so what we're really trying to discuss here today is, what are some of the approaches, tools that are available to just make your job easier and reduce that amount of burnout? So, but I just want to take a step back for a minute and just kind of talk about where we are in context of how management and operations has been done for a really long time. And really, really quickly, we're kind of making a shift right now from paradigm to paradigm, right? We're going from cloud to cloud native, which are these last two things, right? We're really on the cusp. And cloud native, the born in the cloud companies, like customers of ours, like DoorDash, Robinhood, they were born in the cloud. They get this. They understand Prometheus, and they understand observability and open source based platforms and tools. They are all in, and they understand this and are actually doing pretty well with it. There are a lot of companies who are still in this cloud Gen 2 area and really have a lot of questions about how to make the shift to cloud native, or they've already started down the path and they're already seeing what attacks they're putting on their development teams as they make this transition from the old world to the new. And really the focus with cloud native really is about the customer and the end user experience, and using cloud native and cloud native observability to get a competitive advantage, not just keep the lights on. And so, the industry has adopted cloud native, of course, for a lot of really good reasons, right? Speed, efficiency, faster innovation. Again, I mentioned the competitive advantage. But now everyone's environment is a lot more complex than it's ever been. Infrastructure is running on containers, which are very ephemeral in nature. Some of them may be spun up and last for a couple minutes and then be spun down. They scale dynamically. You have very unique operational challenges in that type of environment. On top of that, your applications are built using microservices, which have a lot of interdependencies with other services. And it's really hard to find, there's no single person in an environment who knows how all of this fits together. And so even the fact that these are giving you a lot of the business agility that you want, when there is an incident, shopping cart isn't working, some order processing service breaks down, whatever it is, it's nearly impossible to figure out where to go to fix the problem. And this is despite the fact that if you've employed some sort of observability tool, you have access to more data than you've ever had, because each container microservice is emitting as many metrics as your single monolithic VM-based app used to. So as a result, you have on-call developers who may not be familiar with everything. They don't fully grasp the scale, the complexity, all the interdependencies of the microservices. They don't even know where to begin when that red light goes off or they get that call. And then, so then they end up pulling in engineers from other parts of the organization. They get pulled away from their day job to help troubleshoot this. We're constantly escalating to fix these things. The central observability team is trying to get this under control. They're trying to support the engineers, but they're always dealing, with a whole set of other challenges when this happens, right? Dashboards load slowly, or they don't load at all. Queries timeout. The observability system itself may be down at the same time as your app went down, and they're hosted in the same region, in the same cloud. Now you're flying blind. So that's a huge problem. And then the majority of the central observability's time is spent maintaining and troubleshooting the observability system itself, versus troubleshooting a service or an application that went down. Your business owners are mad. They're looking for answers. They're yelling at people, probably you and your manager. And more importantly, it's like your customers or your end users are really frustrated. They're unable to transact. Has a huge impact on the technical team, a huge impact on your customers. The revenue lost may or may not be recoverable, so it can have a really huge impact. So yeah, lost revenue, customer churn happens. And what we hear all the time is that troubleshooting simply takes longer. The mean time to remediate is that metric is degrading over time. And your engineers are spent in toil. And it also takes longer to ramp engineers up in this environment too, and your costs just go up. And we have to ask the question, like, how did we get, observability was supposed to help with this. So how did we end up here? And so when you had your existing observability software costs initially were probably in line with the value that you were getting from them. So you're spending a bunch of money on observability, collecting all of this data and getting about a fair amount of value at first. But as this scales, when you get to the cloud native environment and it begins to scale, now that value equation gets out of whack. Your observability costs will actually exceed and grow faster than your actual production environment. Your data volumes drive up your costs substantially. More data isn't always better. It can slow you down, actually. It'll make it harder to find the data that's actually important, get that signal from the noise. Performance drops down. As I mentioned, dashboards, queries don't run and don't load. I know Enterprise Strategy Group did a survey in 2021. They found that 71% of companies that they interviewed were concerned about the growth of their data. No surprises there. But PagerDuty actually found that 68% of companies saw an increase in customer-facing incidents in the past 12 months. It's remarkable. Like, we have more data than ever before, and yet our metrics for troubleshooting are actually degrading, even with all that data available to us. What it boils down to is two primary things. And if I can take that whole story and put it into two primary things, right? It's the overwhelming data volume and the complexity of that data, which Eric will talk about in a second. It's overwhelming. And two, for companies that are making that transition, their legacy APM tools and cloud monitoring tools, or if they're doing it themselves with open source tools, they don't really support the workflows that they need, that engineering teams need to support a microservices-based architecture, and we'll drill into each of these things. So Eric, we'll start off with you.
Yeah, so exactly what George is talking about here is sort of what we're picturing here. It feels like the water's rising around you, you're getting buried in everything, the stress levels are going up, you got so much stuff to deal with in the data that's being flooded in that you really can't get can't get back control of your own time. And it just feels like it's spiraling out of control. And that's what this whole talk is about. The shift left is about getting you back to doing what you're doing in the DevOps roles in the dev space, instead of everything being about ops or solving deployment problems. And if we go to the next slide, you'll see a really relevant and very recent thing that was published to Reddit about a gentleman that showed up there and asked, hey, I'm looking at an open source tooling for tracing and interested to see what you guys are doing, and is this something I should care about? And the very first response, you could just feel the sarcasm dripping off this, right? Like, I don't yet collect any of this stuff because I can hardly get our devs to care about metrics at all, let alone traces, right? And then he goes on a little bit later in the thread to say something around, look at the culture. It's really, really, really hard to get anybody to care about just the basic stuff. And I think a lot of that has to do with everybody having that water, up to your lips, and the feeling that you're getting flooded as you expand into cloud native development and cloud native operations in any way, shape, or form. There's an automated scalability and amount of tools you're just getting thrown at you to try and solve these problems. And if we go to the next one, we can kind of give you the overview here of a little bit of what he was talking about with those three phases and what it looks like. And I think this visual brings it pretty well into context, where you're going from very, very simple, understandable environments we can get our heads around, to a little bit more complexity, to absolute explosion in the amount of automation and scale that happens around, especially a successful organization, right? I think the pandemic was a really good example of some of the organizations out there that went from, pretty good business model to, just it blew up just because of the situation we were in. Yeah, and when your services are getting pounded in such a scale like that, and the environments that they're running in a cloud native world automatically scale that out, you're now going to start scaling out the amount of data that's flowing at you. And there's lots of things we really don't like about that. And if we go to the next one here, you see that when you get that scaling going on, originally there wasn't a huge amount of crazy stuff hitting your observation and your observability. But when you get into cloud native environments and you just start scaling up, it starts causing a complexity and these high cardinality explosions that come at your monitoring platforms. Multiple things can happen. They could just fall over. And we're not talking about just a little bit of data. We're talking about a ton of data. And if you have no way to control when that data is coming in, it's just going to be, it's like getting hit by a fire hose. A lot of the analogies we use is, it's like drinking from the garden hose versus getting hit by a full-blown fire hose, right? It's just, there's just so much overwhelming amounts of data that are coming in. And then you're trying to tackle these with different groups within an organization with these DevOps environments. And the tooling you're putting at it is also putting so many different interfaces in front of you. So your teams are starting to get divided up into who's an expert in this area, who's an expert in that area. It gets very complicated very quickly. And in the next slide, we have a really good example, just to give you a baseline idea of the amount of data we're dealing with. I went online and I found a really simple, let's call it a hello world sort of application and demo environment. Somebody was looking at this exact problem. And the links are in the speaker notes of this slide. But we're looking at a hello world app. It's on a four node Kubernetes cluster, so it's not very big at all. They did very basic tracing, end user metrics, logs, and just normal metrics on the containers and the nodes. And that end user metrics was just, an automated pinging the front end of the website. Wasn't doing anything. It wasn't making huge amounts of calls to all kinds of services. That would just exacerbate the problem. And with just this very simple 4-node cluster, with this very simple hello world thing, and with these very simple metrics that we're collecting, if you took 30 days, you're looking at almost a half a terabyte on data. And then if you take the retention rates inside of an organization, on average, 13 months, people are keeping their data, no matter what the environment is. That's just like a blanket sort of rule in the company. Can you imagine the amount of data that's being stored and that you're having to pay for, deal with, shift through, evaluate, your dashboards and your stuff? When you have a problem, it starts getting, you can't find the needle in the haystack. It's getting to be the problem. And leads to the next slide there. And you end up basically with all the things that George was putting in our original discussion there about how the tool sprawl starts getting crazy, how the burnout starts taking effect, how you're just unable to get things done, right? And it wouldn't be a problem with all this data, it wouldn't be a problem with all these costs, and it wouldn't be a problem with all these tools if you were able to solve problems faster, remediate quicker, have better customer satisfaction. But these things tend to just deviate from that plan, right? Making it farther and farther and harder to get those kind of good outcomes. And with that, I'll hand it off and you get a little bit of an idea from George here about what it looks like in the architecture and how that grew.
Yeah, and I think, back to the earlier slide, right? We've kind of focused on like data volume and complexity is one of the big drivers, which I think we've been pretty familiar with for a while now. And now we're kind of shifting towards like, based on that, the workflows are also not a fit for cloud native environments. And even thinking to the data cardinality that Eric just kind of went through, right? Cardinality spikes come for a number of different reasons. Just people want to keep adding fields to what they want to capture, but that leads to a problem with a lot of the tools right now that are available out there. Data management is pretty opaque. It is a very manual job for central observability teams to chase down the big data hogs in their organization and to understand what data they're capturing, what data needs to be captured, and what data does not, because not all data has value. And so that's a big problem with a lot of the tools right now, because when they were built for the cloud world, that wasn't an issue. And now in this new world of cloud native, cardinality, complexity of data management is a really important task, or you're going to run your central observability team and your SREs ragged, just running around in the organization to find out who needs to collect what data is important. You may choose to not collect a certain amount of data, and then all of a sudden a problem arises a couple months later. Oh, sorry, we didn't collect the metrics for that because we didn't anticipate that there'd be a problem and we had to keep our data costs down. Or it could just be an aggregation rule or something that inadvertently removed data that you end up a couple months from now finding out it was really valuable and we need it. So those are the things that really make it challenging for the technical team to troubleshoot issues. And that's where you get this frustration and workflows not aligned too.
Very true.
So how did we get here? Well, of course, it's just all about cloud native, right? And in the software development world, traditionally with cloud, still fairly linear process. And you had a lot of knowns, and ownership of things was pretty cut and dried, I think, throughout an organization. Compared to cloud native, now we have a bunch of interdependent microservices owned by different teams, group of microservices owned by different teams. My microservice depends on this microservice, and it becomes a much more complex infrastructure. And how that affects monitoring in the traditional worlds, I remember, I'm old enough to remember managers of managers, the MOM, right? And you would have infrastructure monitoring and application monitoring, and you'd roll it up to a central monitoring system, and then you'd have your alerts, and then you'd triage down and assign it to your tier 1, tier 2, tier 3 support staff. And it was fairly straightforward. But now in the new cloud native world, we kind of democratize things. Anybody can create a dashboard, and we need that. We need the teams to be fairly autonomous and say, this is what's best for my application. I want to curate the things, all the artifacts, the monitors, everything about my microservice, and then build a dashboard so that I know and I have a view into my service. Unfortunately, with a lot of the tools that are available today, everybody can create a dashboard. They can copy your dashboard, do a little tweak to it. And you actually have some of the vendors now offering tools, workflow tools that will go in and scan the environment for dashboards that haven't been used in, say, 6 months and delete them according to a policy. That's how bad entropy has become in some environments. Now engineering teams don't know which dashboard to go to because there's 100 of them that look exactly the same. Which one do I go to solve this problem? So this has become a huge issue with trying to monitor cloud native environments. So where we are today is we have dashboard and tool sprawl. You've got data locked in proprietary formats if you're using a traditional kind of APM tool. You have, the platform, generally, if you're using a SaaS APM tool, the platform dictates data collection, what you can collect with their agents. And what you have happen is you have this over-reliance on power users. You have on-call engineers who can't find the data that they need to solve a problem. They're not familiar enough with it and all the interdependent services, so they escalate, and they escalate constantly. And this is where your engineers get burned out, constantly having things escalated to them that they have to, and it could be something really simple, but the person just didn't know where to look. And the monitoring tools for that environment have a lot of trouble scaling when you go from hundreds of VMs to thousands or tens of thousands of microservices. Troubleshooting takes longer, the application experience suffers, and your engineers burn out, they turn over. We know this for a fact because we've recruited some of these engineers to come work in engineering and product management for us because they got really burned out by this constant treadmill of fixing broken systems. So what we really need is, we still want to have some centralized control, but the flexibility for the teams to do what they need, but to put some guardrails around it. You want also open source compatibility is huge moving to this new world. That this is the future, and this is what we want. And this gives us the ability to have service owners choose the data that they want to collect, but have guidelines from a central observability team to put proper governance around it, and have tools that can shape that data and help you capture and store the most important data and not all the noise that comes with it. And that way you're empowering engineering teams to do more, to get out of the troubleshooting chase and start innovating more, and actually have your observability be more reliable than your production systems, so that when you do have an outage with your production systems, your observability is still up to help you fix it. That way your troubleshooting is faster, the application experience is better, your engineers are happier, fitter, happier, healthier, as Radiohead would say. And so this is the exact problem, back to the layer cake that I showed earlier, right? This is the exact problem Chronosphere is designed to help you solve. And this is where you can see with your costs out of line, we help you get those costs back in line. And so you can still collect the same data, but it's aggregated and transformed into the actual information that's usable for your developers, while also reducing the overall cost of your observability. So this effectively helps you swing that cost value equation back in your favor so that you're getting better business outcomes. And what that delivers is, again, better MTDD, MTTR, happier customers. You're not losing revenue and having transactions fail. You have happier and more productive engineers because Chronosphere actually shows the critical data that developers need to get to quickly. It democratizes the usage of observability, but it reduces a lot of the toil, and gets engineers back to doing, business value producing things. And your observability costs will actually go down. So how do we accomplish this? And here's where Eric can give us a little bit of background on Chronosphere generally and control plane specifically.
Yeah, so as you can see here, you have kind of an overview coming in from the left, everything that you're ingesting into the system, right? We're collecting that into our Chronosphere platform. And one of the key components and what's hugely valuable here to our customers is the control plane. The control plane gives you the ability to decide what, and this is per user, you see that it's contextualized per user, to give you the knobs and the buttons you need to decide what do I need to do to monitor what I want to know. And that's a little bit what you just saw in that little green line diving down through that layer cake of the data flood. For that specific problem, that person went to their own information and was able to dig down into the problem because they've already gone through with the knobs and dials and decided what's important to me about my service. Am I interested in the CPU usage and all the default things that get turned on like memory? Not really. What I'm interested in is how many times in my retail service that it's being purchased and what's the average spend or something like that might be my business interest. And so my dashboard needs to reflect that. And this control plane gives you the ability to do that. And what you're doing is now putting in the hands, instead of talking about 3 pillars of observability, we're talking about, hey, I'm able to know when something goes wrong. I'm either knowing before it happens or as quickly as possible. I'm able to triage what's going on, and in that space of time, I'm able to remediate the problem. And by saving all that time between the notification, triage, and remediation, instead of having to dig through that huge pile of data and dashboards and all the things that George showed us, we're able to dive into our own specific information because we've pre-filtered in the control plane what's going on with that. But later, you still have the ability to go in and do the root cause analysis and know and understand what the real problem was so that it doesn't happen again. So the first part is to get the business KPIs back in line. The second part is to not let this happen again. After the control plane, that's when you're actually keeping the data. So that's the part that you're achieving the savings on the amount of data that's flooding into you. And let's say, for example, some of these metrics get that cardinality spike we talked about. Somebody releases something new and it just goes off the map, or something crazy happens with the service we didn't account for because of pandemic conditions, and our business goes nuts. And it scales up. Well, you start getting flooded by something like that, you're being notified about it. You can take action and just turn it off, instead of blowing your complete cloud budget for the quarter, and it might be a development team with a new young developer that just decided, I want to know attach a few more labels to this thing so I can monitor some more stuff, not realizing what that's going to do down the road in my test environments. So the control plane is something that's able to provide an almost immediate return on investment, as far as you can visibly see the amount of data that you're able to tune down to what you really need. We have a really nice example where you see a dashboard that has like 130,000 data points, and you can bring it back to 130 and produce the exact same dashboard, which is what it's all about. It's about, can I understand what's going on with my environment with this amount of data, and all that extra extraneous stuff is just white noise. And you see here some of the data points: 50% less time troubleshooting, 48% average data reduction across all our customers. That's something we had to research to take a good look at, but kind of surprised that it was almost a 50% reduction in the amount of data you're having to persist after the control plane. And it's been proven to scale. It scales to 2 billion data points per second. And historically up till now, and we keep saying knock on wood because it's going great, but we've had 4 nines of uptime at scale, right, across all of our customers. And we really can't go any higher than that, because that's as far as the cloud providers will do. So we don't want to hang ourselves out to dry with more nines on the back end that we can't, put our name behind. So that's why it's 4 nines. You go to the next one there.
Yeah, like this was built by the engineers who developed M3 at Uber. They know how to build a very, very scalable industrial grade platform. And the only thing I'll add, Eric, is that 48%, as Eric mentioned, is an average across all our customers. There are some who get a lot more, depending on where they come from. We had one customer that was 80% reduction in the data volume. I don't think they even realized like how much low value data they were ingesting into their platform.
And here you see a little bit more detailed look at what I just kind of described. So you see the ingestion coming in from the left, and you see all the data points you wanted to collect. And that's kind of the funny part, because if you ask anybody, how much data should I bring in? What do we want to do? What do you think? Their natural reaction is, I want it all. I never know what I might need. And that's fine for a global view. But when you start getting down into the teams and the way cloud native development works, and with these DevOps teams, they all own their individual specific things. That's what they're interested in. They're not interested in everything that's going on across the architecture. And when you start getting into traces and spans and stuff like that, it's where it's bouncing all over the organization. That information is extraneous, right? So coming into the Chronosphere control plane is pretty much everything you would normally ingest, and then giving each team the ability to dial that into what they want. And also the ability to set things like a rate limit. So if you have multiple development teams with certain budgets attached, you can let them know or signal them or block it if it's going to go over, right, before it happens. And then you have the time series data stores on the back end. And again, that's all stuff that's come out of, our founders come from the Uber M3 project. They were the original creators of that thing. So they have a real good story around what they're doing and understand very well what our customers are trying to do in this space at massive scale, because they've been there for years and years doing it themselves. Anything you want to add to that? Did I get it all? I feel like we're beating the drum.
Yeah, I think you've actually captured it. So I think to this point, we've talked a lot about the data volume piece and how we get that under control. And that dovetails nicely to, okay, how do we address the end users, the developers' experience here? Because like I said, how do we make their job easier? And the way we've kind of solved that is with us, Chronosphere, coming in January, at the time of this recording, it'll be available in January, is a whole new interface and user experience with the Chronosphere platform. And it has a new feature specifically called collections. And a collection is an organizational construct where developer teams can actually curate, store everything that's relevant to a microservice within a collection. So you can think of a collection as representing a service. And collections, I said, let the expert who knows build the default view of a microservice. And then that's a view that everyone else can use. So collections provide context for engineering teams, and it allows them to more quickly navigate to the data that's actually relevant to an issue. So what you're seeing here on the screen is the team view in Chronosphere. So this view orients the team. It orients you as an engineer on the team so you can work more effectively. And you can actually zoom out and see a global view where you'll see the entire system, all of the collections throughout the tenant. But your primary view will be a view like this. And this example is the infrastructure team. So this is the infrastructure team being able to go in and seeing all of the collections which represent the services that they as a team are responsible for. So now say you have an on-call engineer, and they may not be an expert on your service, but now they can at least quickly navigate to the right data in context so that they can fix more issues faster without having to escalate to one of the leads on your team. So it's a really important thing for us, is that we're trying to design cloud native observability for the way cloud native engineering teams need and want to work. And getting them to the right data at the right time in the right context is crucial to that. Otherwise, you log in and you're just overwhelmed with data, and even small problems end up getting escalated to your most expensive resources, who are called in nights, weekends, missing their kids' birthday parties, etc. Especially now, I think a lot of people are thinking about on-call shifts as the holidays approach here at the time of this recording. We don't want to make people's holidays miserable by having them being called in at off hours to fix simple things. So this is what we're designing Chronosphere to be able to do. So the two things, right? The amount of data, getting that under control, having more transparent data management so that you know who's collecting what, what's important, what isn't, and be able to manage that actively. And then have an interface to the platform that is in line with how your development teams are organized in your organization and how they work, their workflows. And it just makes troubleshooting easier and less stressful. And this is our obligatory marketing slide with our key customer logos on it, right? We really think, observability does unlock competitive advantage. Don't think for a second that it doesn't. How can Uber price an Uber at one point at $50 and then 3 minutes later price it at $60? It's having an instant view into the environment, capturing the metrics that tell them exactly that they can actually increase the price there 3 minutes later. Those are the kinds of things that observability does. So, but again, we give you the ability to control and shape your data, transparent data management. A platform, anybody can offer an SLA. An SLA promised is not an SLA delivered. So you can actually look at the websites of vendors and you can see they have to disclose their downtime and other thing. And we've had customers come to us and saying, 4 nines, we haven't been able to get 2, or 3. So to get 4 is incredible. And we've historically delivered 4 nines. Our SLA is 3, and we've historically delivered 4 across our customer base. Again, getting the right data in the right context to make you more productive, faster troubleshooting, and a world-class customer success team that helps customers with that process of shaping their data and capturing and storing the data that's most relevant to them. And just wrap it up with a quick case study, right? This is one of those born in the cloud companies, Robinhood. And I mentioned the number on the bottom, I think is one of the most compelling, right? A 75% reduction in SEV0 and SEV1 events. And that has just huge implications for the engineering team. They're spending a lot less time having to hunt for data and triage things because there are just fewer downtime events. They saved $15 million compared to managing this in-house themselves.
I bet they're looking forward to the holidays now.
Right? And the latency improvement, huge. And that's another thing. We have a feature within the control plane called Query Accelerator. So if you're coming from a DIY open source model and you've written a bunch of queries, and then you come to our platform, all your instrumentation is good. All you have to do is manage the collectors, and then you can run the Chronosphere software as a fully managed service. But we have Query Accelerator can will look at those queries that are poor performing, and you can use aggregation to speed them up. So dashboards will load a lot faster. So engineers aren't standing there at a screen loading or failing to load. It makes them more productive. And again, mean time to detect, a 4x improvement in that metric, which is pretty huge. And with that, we can get to the Q&A.
All right. Well, thanks a lot, George and Eric. That was awesome. A lot of good information there. So I do see one question from the audience, pretty simple. Will we be getting a recording of the webinar? And pretty simple answer to that one, yes. Yes, you will. Every attendee will be sent a recording of the webinar. I'm not exactly sure how quickly it happens, but it'll be very soon. So you will be getting a recording of that.
And the recording, and I think they get the slides as well. I'm not sure, like a PDF of the slides, just so they can, these links that I'm showing here on the screen, you don't have to, you'll be able to get these. You'll have access to these as well.
That's correct. Yes. Thank you, George. Be getting the slides as well. So all the information that we've talked about here today will be available for you at another time. Feel free to share it with coworkers, with anybody you think might benefit from it. A lot of good information here. Cool. So we'll just give another couple seconds if anybody has one more question. George, Eric, did you guys see any questions come through on your end?
I had one question come in about deployment, which I kind of touched on, right? Somebody's asking about deploying and how our software is deployed. The only thing you're responsible for, again, are the collectors. That obviously has to, is connected with your environment. So you manage the collectors, but the software is deployed as a fully managed service. You do not have to manage any of that. So that's the only thing you're responsible for are the collectors. So again, if you're coming from a world where you're managing like a Prometheus environment or Prometheus plus Cortex or Thanos or something along those lines, and you're already instrumented, it's a pretty simple process to use Chronosphere, and you're still just maintaining the collectors.
Yeah, I was going to also add in into that one a little bit there. Think of the open standards that we use to ingest in Prometheus and open telemetry and things like that. There's protocols that everybody's using. Those things can just be redirected. That's one of the standard things that we ingest, and that's one of our biggest the customer play that we like to do. That they made a huge investment in open source stuff. It kind of grows and snowballs into something where more and more resources are involved with managing that infrastructure and dealing with those problems of trying to get it to scale. And you get to a point in time where it's not cost effective to do that anymore. And at scale, you want to get back to doing your business, your organization, and developing what you want to develop. And that's the shift left stuff. Let's get away from all this infrastructure management and monitoring management and get our focus back on what we want to do for our business and for our customers.
Yeah. Very true. We're all under pressure to deliver better software faster, but it's important we make sure we can deliver for the customer, what they actually need instead of just doing more, right? So it's kind of the idea. Cool. All right. Well, thanks, guys. George, do you have something?
Yeah, I think there was one other that came in and just said, if my team is given ownership of a service that they didn't build, like it belonged to another team, how do we reorganize? That's a good question. Within the model with Chronosphere, you can just simply move the collections that's associated with that service to your team. So that's kind of nice that they are portable. So when you move that collection to a new team, it moves all the contained artifacts to your team too. So when you do a good job of curating those collections, it makes changes a lot less disruptive in the environment.
Cool. Good to know. All right. Okay. I have one question come in here. What do the setup and maintenance look like with Chronosphere?
Same thing, right? It's just the collectors that you maintain. Everything else, the data store, dashboards, managed by Chronosphere.
And by collectors, we're talking about the scraping, right? That's basically the component that does the scraping. So in the case where you've been using Prometheus to scrape, it's basically the same story, and you're just redirecting that to the collectors instead of to Prometheus instance.
Low maintenance is nice. All right, cool. All right. Well, I guess if anybody does have any other questions, you can feel free to reach out to George and Eric. I think they had their contact information up at the beginning, but again, you'll be getting these slides later, so you can reach out to them there, or just visit the Chronosphere website. You can find all their information there as well. And it looks like we'll be able to give everybody about 20 minutes back of their day. So I do want to thank George and Eric for joining us here today. It's been very informative. Really appreciate you guys. And a friendly reminder, at dzone.com/webinars, we've got a bunch of other great events, so you can check those out. We got a lot of good things coming up for next year, so get excited for 2023. And other than that, I want to thank you guys for joining us. Thanks for everybody for checking us out. Have a great rest of your day, good rest of your week, and we'll see you next time.
Thank you.
Bye, guys. Thanks a lot.
Bye-bye.